Welcome to AI Podcast. Today we're unpacking a new EMNLP Findings 2025 paper called MPO, short for Meta Plan Optimization.
MPO. And the headline is what exactly?
Conclusion first. MPO is a plug-and-play way to boost LLM agents by giving them a short, reusable checklist at the top of the prompt, what the authors call a meta plan. You don't retrain the agent itself. You optimize the checklist writer instead, then drop the plan in, and the agent follows it more reliably.
So it's like giving the model a good to-do list before it starts thinking out loud.
Exactly. A calm, high-level itinerary, not a script. Think of it as the route overview you glance at before a road trip. The GPS can still reroute, but that overview keeps you from wandering onto the wrong highway.
Who's behind it?
Lead author Weimin Xiong, with guidance from Sujin Lee at Peking University, plus collaborators. The work appears in EMNLP Findings.
Got it. Now, what problem are they trying to fix? Because agents already plan, right?
They do, but they often drift. In long, interactive tasks like web shopping, household simulations, or science experiments, the agent's reasoning can spiral, take redundant actions, or forget the goal. Prior fixes either bolt on more scratchpad reasoning, which can still meander, or fine-tune the entire agent, which is expensive and tied to a specific model.
Right, and if you swap the backbone model, you're back to square one.
Exactly. MPO targets that gap. Instead of retraining every agent, you train a small meta planner that knows how to write compact, high-level plans that any agent can follow.
Okay, so what is a meta plan in practice? Give me a concrete example.
Say the task is buy a red mug within a budget. A meta plan might say, 1. Identify constraints like color and price. 2. Search and shortlist a few candidates. 3. Compare specs and reviews. 4. Pick the best option and check out. It's short, reusable, and model agnostic.
Nice. And how do they teach this planner to write good plans?
In 2 stages. First, they seed it with supervised learning. They take expert or successful trajectories and distill the high-level steps. That gets the planner to produce reasonable checklists.
So a warm start, and then?
Then they get serious about quality. For a given task, the planner samples several alternative meta plans. The team runs the agent with each plan a handful of times to see which one actually leads to better outcomes. Those comparisons become preference data.
Like a taste test for plans.
Exactly, and they optimize with a preference learning method called DPO, so the planner learns to favor the plans that led to higher rewards in practice.
Why not just keep fine-tuning the agent end-to-end and skip the extra planner?
2 reasons: portability and control. A separate planner is easy to carry across agents, open or proprietary. And when the environment changes, you can update the planner without touching the agent weights. It's like swapping the playbook without changing the quarterback.
Love the sports analogy. How do they use the plan at runtime?
Simple prompt surgery. They put the meta plan at the top of the instruction section before the agent begins its step-by-step reasoning. That placement matters. If you bury it inside the chain of thought, it competes with the model's own reasoning. Up front, it frames the job.
Makes sense. What did they test on?
3 popular agent suites that cover different skills: Science World for textual lab-style experiments, ALF World for embodied household tasks, and Web Shop for goal-directed browsing and purchasing.
And the models?
A mix: open and closed models, from compact llama-style backbones to larger conversational models. The point is breadth, not allegiance to a single system.
Okay, but did it actually help? Or is this one of those ideas that sounds good in principle?
It helped. They report consistent improvements across those benchmarks. In plain English, agents made fewer wasted moves, hit goals more often, and held up better on unseen tasks. The mid-size models seem to benefit the most, which is practical if you're cost-conscious.
Mid-size sweet spot, I like that. Did they dig into why it works?
2 angles. First, the meta plan acts like a prior, nudging the agent to structure its search. Second, because the plan is optimized on actual outcomes, it avoids the trap of pretty but unhelpful instructions. It's not just writing nice prose, it's writing instructions that pay off.
What about ablations or design choices? You mentioned the placement matters.
Right. Putting the meta plan in the instruction block was best. Dropping it into the agent's thoughts or observations hurt performance, probably because it clashes with the model's internal reasoning style. Also, preference optimization beat plain, supervised learning of plans, and sampling a small set of candidate plans per task, then picking winners based on trial runs gave a good cost benefit.
So how heavy is this to run? If I'm a practitioner, do I need a lab full of GPUs?
Training the planner and running those trial rollouts isn't free, especially if your evaluator agent is large. But once the planner is trained, inference is light. You're just generating a short checklist and prepending it. And interestingly, because the plan reduces wandering, you can save steps downstream.
So you spend compute once to get a reusable planning assistant.
Exactly, and you can reuse the same planner across different agents or swap in a smaller base agent where it still helps.
Let's talk about caveats. What worried you?
A few things. First, when you judge plan quality by a small number of trial runs, you can get variance. If the agent is stochastic, 5 attempts might not be enough to rank plans confidently. Second, the quality signal comes from whichever agent you use for those trials, so biases from that evaluator could leak into the planner. Third, collecting rollouts on complex tasks can add up in compute.
So the estimates can be a bit noisy, and the bill can grow if you're ambitious.
Right. The paper is upfront about compute and limitations, and they share code, which helps reproducibility. But more rigorous statistics and cost-normalized metrics would strengthen the case further.
Any ideas for where this could go next?
A few. One is a unified planner trained across many domains, with tags to adapt the tone of the plan so you don't maintain a separate planner per domain. Another is smarter search over candidate plans, like using bandits or tree search to find good plans with fewer rollouts. Also, shrinking the planner so it runs cheaply on edge devices. And I'd love to see controlled closed-loop editing, where the agent can suggest a small tweak to the plan mid-flight without losing structure.
Kind of like an experienced pilot adjusting the flight plan when the weather shifts, but still following the core route.
Exactly. Small edits, big stability.
I'm curious about how this compares to, say, React or Reflection, where the agent keeps notes to itself. How is MPO different for a practitioner?
Good question. React and Reflection teach the agent to think and reflect during the task. MPO gives the agent a concise map before it starts. You can combine them, but MPO's advantage is portability. It doesn't ask you to retrain your agent or adopt a specific reasoning style. It hands you a vetted checklist that any agent can read.
And that's appealing in production, because you can test it without rewriting your whole stack.
Precisely, it's the smallest viable change with clear upside.
Quick nod to the team again. This is led by Weimin Xiong with Suzhen Li's group at Peking University, right?
Yes, with collaborators as well. The work lands in EMNLP findings, which is a nice venue for fast-moving ideas with solid experiments.
All right, can you give me the coffee nap takeaway?
Sure, if your agent keeps getting lost, don't rush to retrain it. First, teach a tiny planner to write a good checklist. Optimize that checklist using real outcomes, then paste it at the top of the prompt. It's simple, transferable, and it stabilizes planning across very different tasks.
And the fine print is to watch the rollout budget, expect some variance when ranking plans, and keep an eye on generalization.
Exactly. But as a practical knob to turn, MPO is a strong addition to the toolkit.
This was great. I can see teams trying this as a first-line fix before spinning up a full fine-tuning run.
Same here. That's our show. You've been listening to AI Podcasts. Thanks for hanging out with us over coffee and research.
See you next time.